All right, so thanks for having me. As you just heard, my name is Tarak, and I work here at the university in a department called University Development and Alumni Relations. We can just call it fundraising for short. That's what I'm going to be talking about. I'm going to be talking about this thing that I built called the Discovery Engine. But before I can do that, I need to give a little bit of background about setting up the problem and so forth. So Berkeley, the University of UC Berkeley, raises approximately $400 million per year in various types of private philanthropy. Of that, over half of it, between $200 and $250 million a year, is gifts from individuals or private family foundations. And the distribution of those gifts from individuals and private foundations is such that the top 1% of gift sizes accounts for over 80% of our fundraising totals each year. So you heard that I work on major gift fundraising. That's what that means. So we're talking about the largest gifts and gifts that often involve very personalized and customized solicitations. The office that I work for specifically is called Prospect Development. And so in order to talk about that, I need to mention one fact really quickly about Berkeley, which is that fundraising is largely decentralized. So instead of thinking in terms of fundraising of Berkeley as one large nonprofit, it helps to think of it as 40 or 50 smaller nonprofits that sometimes work together. And so my office, Prospect Development, we are kind of, we are central. We work with all of the various fundraising operations around campus. And we serve as kind of information consultants for all of the fundraising that happens. Among the various jobs that we have, the one that's most relevant to my talk today is that we are called upon to identify prospective donors. Often in the fundraising world, these are called prospects, for specific types of initiatives. So where were we before the Discovery Engine? We work off of a relational database, an Oracle database, and I will be talking at times during this talk about the database. And just know that that is the result of a large amount of work in lots of systems. It's not like there's just one transactional system that makes everything go. But we do have one data warehouse where we try to bring in all of the data that we're generating, whether that's kind of ticketing information from Zellerbach or from football games, or whether that's academic information from student information, as well as data that we build up ourselves. So for instance, I write scripts to match our alumni data against things like political giving and SEC filings, so we can find out like who knows who and whether people are rich enough to make one of these huge gifts and so on and so forth. As well as like people's kind of philanthropic interests. So another thing that we look at is IRS 990 filings and stuff like that. And in that database also, there's two ways that people interact with it. Our office, Prospect Development, is roughly 20 people, give or take, depending on when you count. Two of us have jobs like mine, like a data analyst. The rest of them are, they're also called analysts, which is a little bit confusing for this context, but I'll talk about them as kind of subject matter experts. So they are assigned to individual units on campus and will be very knowledgeable about what those units' fundraising priorities are, as well as they, for instance, if somebody is assigned to engineering, she will be very familiar with the industry in which most of our engineering alumni end up in and so forth. So they're just experts in particular domains. And they do not access the database through writing SQL queries and so forth. They do it through a web-based interface where you look people up, basically. In addition to all the kind of data that you might imagine is in there, we also build machine learning models to do things like generate suggested ask amounts, as well as to identify specific types of solicitation strategies. So you might look up somebody in the database and see that they're going to be more likely to respond to a scholarship ask, say, than some other type of ask. So what was the problem? It basically comes down to this idea of a constituency. Most of the giving, especially these high-level gifts that we're talking about, is what's called restricted giving. So people don't just write checks to the university and say, spend it however you want. They sign proposals often that lay out precisely what kind of research that this money is going to be used for, or what types of, if it's a scholarship, like who is an eligible student for this particular scholarship. And so different programs obviously are going to have different kind of natural constituencies. As a way to kind of wrap your head around this, if the Haas School of Business is trying to raise money for some new program that they're starting, it wouldn't make sense if we didn't know anything else about her to suggest that the first person we cold call is somebody who just graduated from the School of Optometry and has never expressed any kind of interest in anything that's happening in the business school, right? So that's an easy example, but it helps kind of understand what's going on. Those kind of subject matter experts that I mentioned before, who I work with, are often in the best position to make determinations about who is or isn't a natural constituent for a given program or initiative. Unfortunately, the way things stood before the discovery engine, it was difficult to kind of build those constituency definitions in the database and kind of identify the right people without certain technical skills. And then you have this problem where the people with the certain technical skills, mostly just being able to write SQL and knowing the particular layout of our data warehouse and stuff like that. The people who have those skills are not necessarily the people who have the kind of subject matter skills, and there's some loss in that communication. And so what we'd really like is some kind of help putting the tools to define and even discover these sorts of constituencies in the hands of the people who are best equipped to make those decisions. To give you like a more concrete idea of why this was becoming a problem, these are some names of institutes that have come up at Berkeley over just the last several years. And I picked these because they're all explicitly multidisciplinary, maybe even more than multidisciplinary. They just think about the Berkeley Food Institute. What would make a good constituent for the Berkeley Food Institute? It's a brand new program. There is no such thing right now as a degree holder or a past donor to the Berkeley Food Institute, so there's no kind of existing population from which to pick. And it's not like it doesn't lend itself to, for instance, like a machine learning classification type of task, because we don't have labeled training data. That's not really what's going on. This is kind of a search problem. But off the top of my head, even as like somebody who's not super involved in the operating of the Berkeley Food Institute, I can think of things that that might make sense to think about when I'm thinking of constituents for this program. For instance, people who sit on the board of their local soup kitchen, or people who have contributed to a municipal soda tax campaign, or to the extent that we've thrown events on campus about food security, people who've attended those events, as well as people who've majored in nutrition, and so on and so forth. So these constituencies, the idea here is that they do exist in the database, but that process that I just described to you of kind of coming up with things off the top of my head has a couple of problems. One, I just came up with them off the top of my head. And two, even if I was really good at that part, where do I find, so all of the stuff I described, some version of it is coded in some way in the database through all those processes I described before where we're pulling stuff in. But how do I find it, especially if I'm not super familiar with the layout of the database, and why would I be if that's not my job? So to express kind of the issue as clearly as possible, we need a tool that allows us to both define constituencies when we know things like I just did, as well as to discover constituencies if I don't even know exactly what I want to look for, but I know who I'm raising money for or something. And I say that I want the tool to be simple and easily extensible. Simple here means a couple of things to me. One is that this is something I'm building, so I just need it to be simple to maintain. I'm not going to like hire a bunch of people to work on it. But simple also means something that's going to be accessible to a broad enough audience, in particular, subject matter experts who may or may not have coding experience. So I'm just going to do like a short demo of the solution that I came up with. The solution is an R package. But that said, I suspect that most of the users of this tool would not think of themselves as R users, and that's kind of intentional. The tool kind of stands alone in some ways. So it's called the Discovery Engine. That's hence the name of the talk. And the basic idea, going to that first problem I introduced, which was defining constituencies, is It's based on the idea that you can define any constituency of entities in the database using one or more predicates. What do I mean by predicates? Well, for instance, majored in mathematics is a predicate. It's a way you might describe people who happen to major in mathematics. And so the idea is that one or more of these together can precisely identify any constituency for any program. And then from there, we can do the follow-up work. For instance, I mentioned that we have models to generate suggested ask amounts and stuff like that. So then we can like further filter if we know that we're raising money for an endowed professorship, and those only go for 2 million or more. So we're not going to like ask people who aren't able to make that size of a gift and so forth. But the first step, defining this constituency, that's where we are. So when you run, so if you're familiar with R, you'll notice that these predicates are just built up using functions. We've been calling these functions that make predicates, like majored in, widgets. And there's a bunch of things that I'm mildly embarrassed about, including these names like widgets. This like started out as a bit of fun and then turned into a useful thing, and the names stuck. So when you run one of these functions to create a predicate, what you end up with is just a data structure. And the data structure, if you're familiar with SQL, is something that is very easily translated into a SQL query, but it's just kind of a temporary representation of the predicate, right? And it encodes certain things about our business practices and stuff. So for instance, what it means to be a degree holder and so forth. And then of course, as I mentioned, these predicates are very easy to convert into SQL and run against our data warehouse. And so one of the ways that you can display results is just to get a list of the IDs who satisfy your predicate, basically. And there's all sorts of other output things, but for reasons of both privacy and time, I'm just going to talk about this one. But you can imagine the ways that you might want to like have the next step set up for you if you're doing an analysis project versus some other type of thing. Okay, so each of these widgets, they correspond to some set of codes or descriptions. And as you can imagine, for something like a major, there's several hundred majors available, and nobody has like memorized all of them. So every single widget also serves as kind of a ad hoc search or lookup tool. You just add a question mark to whatever you wrote in there, and you can search. So here's every major code that we have available that has the word math in it. And you'll see here that there's both codes, which are the actual representation in the database of different majors, as well as these synonyms or code descriptions, which there's a big kind of dictionary table in our database of which codes stand for which descriptions. And in the discovery engine, you can use the codes and the descriptions interchangeably. Okay, and then of course, there's a lot of widgets, so they're all indexed by keywords, so they're very easy to find. So if I know that the kind of data that I'm interested in is degree-related data, I might search for a widget for degrees and find all of the widgets that touch that. In practice, what most people do is they pull up this little, they pull up this little thing and they work from it as they go, kind of, right? And they just leave it open while they're working. Okay, so what makes the discovery engine actually useful, so far we haven't seen much very interesting, is the idea of combining multiple widgets using different logical connectors like and or not, as well as composition. And so for instance, if the math department was throwing an event on campus and we wanted to figure out who we wanted to invite, right? We might start by first defining what it means to be a fan of math or to be a mathy person. And in this case, I'll just define it as anyone who's majored in either math or applied math, or who's ever given to the math department. And so you can see that the kind of setup, the syntax sounds a lot like what I just described to you in just normal language, and that's intentional. Now I want to find people who are kind of close enough so they would actually attend. I don't want to be inviting alums who live in Rhode Island. So I want to look up the codes associated with the metropolitan areas of San Francisco and San Jose. And I see them. Okay. So then I define what it means to be both local and into math. Run that. And then for this project. Let's just say I'm done. So I'm just ready to move on and display them. And so you can see, hopefully, that this is a valuable way to kind of think about populations of entities in our database. OK, so that gets us to the idea of defining a constituency. And as I didn't mention earlier, there's nearing 70 of those widgets. And given all the different ways you can combine them, and you can kind of combine them endlessly, you can make definitions as long as you want. So there's a very large, well, countably infinite number of definitions you can create. So what about, maybe not infinite. So what about discovery, right? So we created, again, another name I'm slightly embarrassed about now. We created bots that do the discovery side. And they kind of generate predicates for you based on search terms and so forth. So the first one is maybe the easiest to understand. So just going back to our Food Institute problem, maybe I would just do a general search for food. Great. And let's take a look at what came out. As you can see, I think it's hopefully obvious how this search works. It's just looking for the word food. And so there are all these events that mention food, and that would be good to know if I was working for the Food Institute, right? And there are, I'm not going to explain some of these names for these predicates, because some of them correspond rather closely to the names of the screens when you use the web interface to the database, which is what most of the users of this tool are using. So there's like, so it makes a ton of sense to them, and it may not make a ton of sense to you. Like, for instance, what is the difference between an interest and a philanthropic affinity, or whatever. But just know that there is a difference. OK, so you can see that that is like a fairly quick way and a fairly low-tech way of kind of very quickly pulling together candidate constituencies for the Berkeley Food Institute. And I won't go through all these examples, but you could do the same thing for the Silk Road Studies program or for the BRAIN initiative. OK, so we had that working, and things were going fairly well. I happen to really enjoy going to the libraries on campus. That's actually why I applied to work here. And now, 11 years later, I'm still here. And one of my favorite things is when you look up a book and you go over to the shelf where your book is, you see all the books that are next to it. And sometimes you get one of them instead of the one that you wanted in the first place. And so I wanted something similar when we do the kind of search through the database for entities. And so the way we do that is we made this matrix bot, which looks for, I guess, what I'm calling nearby or adjacent predicates. So an example will help again. So let's say I start out by defining just music majors, anyone who majored in music, right? Then I run the matrix bot on that existing definition. And I pull out, again, the results look like before, but all of a sudden I'm seeing results that don't even mention the word music, but are clearly next to music on the shelf where I would go. So that's the way that works. And as it turns out, the bots themselves, so going back to the idea of a tool being as simple as possible, for me what that meant was that every kind of every function that you create in this tool should output the same type of object, in this case, a constituency definition, what I'm calling a constituency definition. That includes the bots. That's all they output. So that means that they, too, can be chained together. So for instance, here, if I was looking for donors to the Institute of Data Science, I might run just a plain text search for the word data, but then like kind of run those results back through the matrix bot. And I come up with results. I'm not going to go through every single example for you, but every single result for you, but just to get a sense of what ends up happening. You end up with results like, oh, you should talk to people who majored in statistics or computer science. So this seems super obvious, hopefully, to people in this room, but there isn't actually that metadata in the database that explains that statistics has anything to do with data. So these are like associations that are being automatically kind of surfaced when you do this search for the word data. OK, so that's it. defining and discovering constituencies. All right, so, and hopefully you'll agree that it's simple, and you can take my word that it's also easily extensible. All right, so I want to kind of go over how it works and why I think it is a good solution to the problem that we had. So in terms of how it works, what does it do in order to allow you to define a constituency? I'm purposely making it sound more impressive than it actually is, by using these language metaphors, not because I'm trying to impress you, but because the idea of language was very much in my mind as I was building this. I think none of the people who use this tool are or were coders, but they all write emails and stuff. And not that they were going to end up writing kind of natural language queries or anything like that, but it was important to have a system that was expressive in the same way that my colleagues are expressive. Okay, so we have this vocabulary of standalone predicates, as you saw, these widgets, as well as a grammar. And here by grammar, I just mean ways of combining simple definitions to create more complex definitions. And of course, along the way to creating those complex definitions, you have the ability to assign names. Of course, I didn't invent variable assignment in R. That was already there for free. But it's important, again, to think of that as one of the important components of what makes this work. Because, for instance, a lot of people in my office are much more used to point and click tools. And there isn't a great analog for variable assignment when you're doing a point and click tool. But as you can see, having those variable assignments actually makes the end result much more easy to read and makes the whole language more expressive. So a little bit of background of what's happening here. There were some fundraisers who they wanted to hold an event for the parents of first-year students who were in the marching band. And they thought it would be a good idea to invite parents of recently graduated band members. So I guess they could talk about what it's like being parents of band members. So that's whatever. They didn't end up doing it. It was just an idea. But that's another advantage to a process like this, is that we can rapidly come up with these things and then throw them out when we realize that they were dumb ideas. So what you're looking at here, the first piece just defines what it means to be a recent band member, right? And then the second piece just defines what it means to be a parent of somebody like that. And then finally, we want somebody who's near enough to the location that the event's going to be held that they might actually come to this event. Again, same idea. And then this one uses geocoding. So we convert Claremont Resort to latitude and longitude and then search the database for 25 miles within that. Right. So another thing that's possible, which I'll talk a little bit more about a little later, but just looking at this, I think everybody in this room, as far as I can tell, nobody in this room has used our alumni database. And yet everyone in this room, I think, can figure out what's going on in this code. And that's kind of the point, right? Even if you couldn't write it yourself, that you could read it so that we can bring it up in meetings and say, are these the right years? And a fundraiser might say, actually, go back to 2005. That's young enough for us, whatever. All right, and then we saw an example of discovering constituencies, right? That we could chain together these bots and we could put in plain text and that we see results that are meaningful. And this becomes especially useful in areas that are not data science where you wouldn't know what the appropriate majors to look for are. So we solved, I think, the problems of defining and discovering constituencies in a way that I thought, personally, was just really satisfying. I think that there's additional kind of side benefits that I think are important to kind of lay out. And one that I alluded to earlier is the idea that a tool like this, a very simple language like this, allows for easier communication and more collaboration among people who have potentially different skill sets. So again, quick background. We have a neuroscience institute on campus. And they do cool work. And as it happens, there is neuroscience-related research that happens on other parts of campus that aren't necessarily happening under the umbrella of the Neuroscience Institute. But it may be of interest to the people at the Neuroscience Institute who are the really big donors to that type of research all in other parts of campus, because we would like to make sure that they are getting the same sorts of communication and the same sorts of opportunities. If like one of our professors is giving some public lecture that has to do with neuroscience, the person who made a large gift to like the cognitive science or some kind of data science thing that has to do with brains would most likely like to be invited to that. And so the idea here, oh, and I should mention also, that individual funds or allocations that people can give to, in addition to a name, they have tons of documents associated with them. So unlike some other parts of our database, the part where we actually think about giving and money is very like well kept up and structured. And so they have a number of documents, including what's called a fund biography, which has like the narrative backstory of how this fund came to be, as well as fund terms, which lay out in very explicit language how this money can be used and what sorts of research is going to be used on and so forth. And so this first step here, so kind of in response to that original question of like, can we find people who've given to those funds in other parts of campus to funds that may not explicitly be coded as neuroscience funds. Again, like if something happened through the cognitive science department, maybe they just call it the cognitive science fund or something like that, but it might have gone to very much neuroscience type research that the Neuroscience Institute is interested in. So we searched through those documents I mentioned for any word that starts with neuro or the word brain. We look for people who've given at least $10,000 to those funds as kind of an arbitrary cutoff. And then one last thing you should know is that unit portfolio is the kind of way people talk about the portfolio of relationships that they're in the process of cultivating at any given time. So the unit portfolio for neuroscience is kind of a proxy for like who's already on our radar. So here we're looking for people who've given to this type of research in the past, but who we're not already cultivating actively some kind of relationship with. And so going back to the idea of easier communication, this was something that we could bring up in a meeting like I described before and kind of get buy-in from different people who wouldn't necessarily have written this code themselves, but who are perfectly comfortable saying the cutoff should be $50,000 or whatever. Okay, thank you. All right, so in the next 5 minutes, I will describe how it is that I think, what tricks I use to kind of make a tool that has these properties like that make it communicative in this way. So one is this idea of syntactic noise. I didn't come up with the idea. There's this book called Domain-Specific Languages by Martin Fowler. And one of the things he describes is the idea of syntactic noise that's kind of syntax elements that aren't actually about the content of the code, but rather just make the code work in a particular language. And so one way to like make this code readable to non-coders was this idea of like minimizing the amount of syntactic noise that exists in any of the expressions that you can build. So here, for instance, is the syntactic noise in this disco engine thing. If you use R or some other language, or in general don't take advantage of non-standard evaluation in this way, you might be more used to code that looks like this. This would do, in theory, the exact same thing. And so in some sense is equivalent to the code that we just looked at. But my feeling is that this is not something you can bring up in a meeting with a bunch of different people at different levels and say, what do you think? And the reason, I think, is because it's noisier. So that's what I mean by minimize syntactic noise. And then finally, the idea of like making these things flexible enough to address real needs without like over complicating them. And so most languages, and R is one of them, allows for optional arguments or default values to arguments. And so to take advantage of those liberally, so here you see in orange like progressively a function call that's getting more and more complex, but it only has to be as complex as you need it for that particular purpose. So by the time you get to this third level of complexity, you're doing it because you actually want that level of specificity, and so you're comfortable with that. Finally, going back to kind of rolling out a tool like this to users who do not think of themselves as coders, but I also think that this is just good advice for any piece of software that you're going to push out to anybody. Have really clear and available documentation. So we made a website that has tutorials, examples, step-by-step installation instructions, and so forth. I've been leading trainings for both when we have new hires or when people want refreshers. And then this sounds really obvious, but I it doesn't happen often in real life, is just like clear error messages that tell you exactly what you did wrong and a good way to fix what happened. And so that's actually been one of the best ways that I've been getting feedback from users is like, they'll be using it and everything's fine, and then eventually they'll send me an email and say, I got this error message, I have no idea what it's asking me for. And instead of just being like, oh, here's what you did wrong, and then kind of not thinking about it anymore, I open it explicitly as an issue and eventually get around to finding out what they did and creating an error message for that exact type of situation so that the next person who has this problem can fix it themselves without having to email me. And that's one of the many ways that I've been trying to seek and enable contributions. But the basic idea, again, is like to make things clear. And I think of all of these things as various forms of documentation. So even the error messages are a form of documentation. Thank you.
That's great, Tarak. Thanks very much. We have maybe a couple of minutes for one or two questions. If there are some, Mark, let's take a mic down here, and then we'll go there second. Thank you, right in the middle here. Okay, we got 3 lined up. Great.
Thank you. That was a great presentation. I had a question. Once you implemented this discovery engine, what kinds of organizational changes did you find were necessary among the people who actually reached out and spoke to the potential donors?
Sorry, organizational changes for
Once you implemented, I'm presuming if I understood this correctly, that your discovery engine was to discover potential donors for potential programs. For those people who actually reached out and made contact with the potential donors, did you find that there were organizational changes, communication changes between your group and the ones who were actually the donor-facing contact?
Yeah, so I should say a couple of things. One is that since it's been in general use, it's been like less than a year, so I can't make comments on any kind of like huge sweeping changes that have happened in that time. These sorts of solicitations themselves can take several months, so, but certain things have started happening. So one is just that certain things that used to not be self-service became self-service. So which was not like the stated intent of this tool, but a lot of people are doing work for themselves that I used to have to do for them. There's, in addition, sorry, that's like a larger change that I don't have the time to get into, but we've also just sped up certain processes. So actually, like, this is one level. So the output of this is not immediately going into communication with a prospective donor. It goes through, I mentioned, our like kind of subject matter experts, and they will like review some of the names that come up through searches like this and decide on the best ones for actually kind of like the last presentation, like that human in the loop idea, I guess. And then they will, like they have weekly meetings with their clients, and they will be like, here's some people who I really think you need to talk to for this initiative that's coming up. So that work has been both happening faster and anecdotally they've been coming up with better names, but I won't know for maybe another 6 months or so, like in terms of like, does that mean more gifts or different types of gifts or what?
Great.
Can you talk a little bit about the thinking you went through when you created those adjacencies that you talk about?
Yeah,
So you describe going to the library and looking at the books around the book that you specifically searched for.
Yeah.
What's your thought process in finding the adjacencies in your database?
So the high-level thought is just that. I just really like the library. I realize that this is not like a unique application and that this happens in other places. For instance, like when you're on Flickr or some kind of thing that's tagged, you get suggested tags. So if you type in like tree, it'll be like, do you want leaves and bark also and stuff like that, right? And so it's like a similar idea. For me, though, it was like the library thing, and then okay, so the people who are using this, we all use extremely low-powered machines at work that don't have very much RAM or very much processing power. So, and we're constantly, well, I have slightly better access to machines than they do, but we're trying to come up with solutions often that work on really low-powered things. And we're not like sending things off to the cloud necessarily, like we keep our data in-house. However, in that environment, it so happens that our IT people spend a ton of money maintaining this Oracle database, which is like super powerful, but everyone thought it was just useful for like reporting giving totals each year, and that was it. Or then when I came on, it was like for making machine learning models to identify prospective donors, and that was it. And so I was interested in it almost as a cloud server. Like, it's super expensive and super powerful. So I figured out how to do matrix multiplication in SQL, and then just sent. So it's what's happening when you do this is you're automatically generating a query that's like creating an adjacency matrix of kind of tags by tags. But that started out also as like a bit of fun. I was just like, isn't this neat? I can do matrix multiplication. And everyone was like, no, not at all. But I proved, you know, that it was it took a while to get from that idea to this kind of actual useful tool out of it. So for a while, people were like, I guess that's neat, but I don't know why that's useful to me. And somehow those ideas, the thing about the library and the thing about the matrices, kind of like fused in my head one day, and that's what happened.
Great. All right, Tarak, thanks so much. Please join me in thanking.